Hey everyone, welcome. As you heard, my name is Paulo. I'm the current Django CMS lead developer. I work for an agency called Divio. And on a more personal note, I like hiking, nature, and all sorts of outdoorsy stuff, right? So, let's talk about speed. The speed, not the other type of speed. Speed is important, right? Whether you're working on a client project or you're working on an application you're going to distribute to other developers, it's important, right? So this talk is composed of things I learned while working on a sprint to improve performance on Django CMS. So I hope you guys find it useful. The talk is divided in 3 topics. The first one is Django ORM. The second one is templates, Django templates, not Jinja or anything like that. And the third, a small note about third-party applications. Throughout the talk, I'm going to be using an example model. This model is called Hotel. It's really simple. It has a name, city, postcode fields. It has a modified on timestamp, when was it last saved. And it has a manager field, which is like the hotel manager, which points to a Django auth, that user model, right? So, Django ORM. I've divided into 5 subtopics. The first one, prefetching, then BothCreate, the _ID trick on foreign key fields, saving, updating, and fetching from the database. Prefetching. Prefetching is like the most common optimization technique in Django. That's like everywhere. And so I'm not really going to go too deep into all the options because it's really common. I'm only going to just touch it briefly. So there's 2 main ways to do it, like 2 options you have available. The first one is using select related. The second one is using prefetch related, right? Select related works for one-to-many fields and one-to-one fields, right? So manager is a foreign key, one-to-many. And so imagine you have a query set of hotels, right? And you have to access the manager for each hotel. So you're looping through the hotels and you're doing hotel instance manager. If you were to not use select related, then you would make a query for every single hotel in that query set. So if you have 200 hotels, you're going to make 200 queries. So if you use select related, then Django will prefetch all the managers for every hotel instance. And so calling .manager will not execute any more queries, right? Prefetch related works exactly the same way, except that it's for many-to-one and many-to-many fields. And imagine if we have another model called hotel photos. And this model has 2 fields, an image field and a foreign key to the hotel model. So if we are again in this query set and we're looping through each hotel and we want to know, give me all the photos for each hotel, we would end up making a query for every single hotel in the query set, right? But if we use prefetch related, we can pass in the reverse related name, basically, in this case photos, and then that would prefetch all the photos for every single hotel, right? So these 2 are like really straightforward. Then BothCreate is also really common. This one is, imagine if you've got a list of hotel instances. They're not in the database yet, so you have to save them, right? You could just iterate over all the hotels, for hotel, in hotels, hotel that save, but that would make an insert for every single hotel in that list, right? So Django gives you BothCreate, which you pass it an instant, like you pass it the list of hotels that have not been saved in the database, and Django will execute a single query of the size, of the batch size. So the batch size depends on the database. You can also pass in the batch size parameter, but normally you can create at least 200, 300 records, so without a problem, right? Batch size will be high. Like on SQLite, I think it's 999 if I remember correctly. So yeah, you can create a bunch of objects in one single query. And here's an example. I've got create v1 and create v2. Create v1 does for hotel in hotels, hotel that's safe, right? And create v2 just does a bulk create. As you can see, create v1 takes 6.5 seconds to execute, and create v2 takes 0.4 seconds to execute. So the difference is substantial. And these numbers are from my machine, so they're going to be different on your machine, but the difference should always be there, right? Next is the underscore ID trick, right? Imagine if, again, you've got your list of hotels and you want to know quickly if a hotel has a manager, right? The manager was a nullable field. I don't know if you noticed, it was a nullable field, so meaning it can be none. And so you're in a loop and you're saying if hotel that manager, if the hotel has a manager, right? But you only want to know if the hotel has a manager. You're not necessarily going to use the manager yet. You just want to know if it has one. So if you were to do if hotel that manager, if it has one, it's going to make a query to the user table and fetch it, right? But you don't really need it at that moment, so it's really inefficient. So if you have, out of the 200 hotels you have, 100 of them have a manager, you're going to make 100 queries. Obviously, if you don't use select related, right? So in Django, normally, when you define a field, like in the case of the hotel model, I define name equals models.char field. Django will then create a name column, unless I overrode it in the field definition. It will create a name column in the database table. So, but for foreign key fields, it's different. My field is called manager, but the database column is called, but the table column is called manager underscore ID, which points to the ID of the auth user table, right? So manager in and of itself doesn't represent the actual column. It's more like a virtual field in a way. So this is why instances will automatically get a foreign key field name underscore ID attribute, which you can then use to quickly check if this instance has this foreign key, right? So in this case, I can do hotel.manager underscore ID and easily check if it has a manager without making any queries at all. Saving and updating, right? So normally, when you save, right, you just do hotel, you would do hotel.save, and Django will automatically just grab all the columns in your table and do an update of that, right? It will just update everything, every single time you do a save. And if you've got a lot of fields, a lot of columns, it's going to do that like every single time. So if you're doing this on a loop or something like this, it's going to update all the columns all the time. And that can be quite inefficient. So Django gives you the save, but you have an option. You have the update underscore fields, which you can give to Django, and Django will only update that field. So as you can see, I have set new manager v1, very simple function, right? It just sets the manager on the hotel, and the first version calls save. So when I call save on the first version, Django will not just set the manager, it will set the name, all the other fields are going to be set in there. But v2 will only set manager. So if the model has 100 fields, it will only set manager and not all the others. Then there's a third option. The third option is you can use .update. Query says have a .update method, which you can call with the fields you want to update and the values. And that will be more efficient than save because you bypass all the signals. So an example from Django CMS is we've got a lot of signal handlers that listen for when content changes. So anytime something is saved, there's a signal handler that gets executed and does a bunch of operations, right? But when we're working on the core internally, we don't necessarily need these signal handlers. These signal handlers are for third-party integrations. So for ourselves, we don't need them. So this is one way we bypass these signals. We do an update directly and then just forget about the signals completely because we don't need them. They're more like housekeeping work. Now, if we were to run this on a loop, then one could say that this is a little bit inefficient because I'm doing hotel.objects, that filter every single time. And if we're doing it for 500 objects, then it's a bit inefficient, right? So I created a fourth way, and it's a much more over-engineered, but it just illustrates a point, right? I've got set new manager before, which takes what I call the lookup. And this way, the dot notation is outside of the for loop, right? Now, I wouldn't do this necessarily on production or something like this, but it's just a way to illustrate the point, right? There is a gotcha here. When you use update fields, right, you're telling Django only update this field. But if you're working with third-party models, that can be a problem. Because imagine right now I created this update manager data. It takes the manager, which is a user instance, keyword arguments, which map to field names and values in the user instance. And then if I were to do manager.save and I say, well, update fields equals all the fields that were passed in, right? What happens if Django were to have, Django's user model has a first name and a last name. What happens if they were to add a full name field that concatenates the two values from first name and last name and stores them as full name? And they do this logic on the save method. And I've seen this a lot, not necessarily in Django, but in other apps, where the save method uses values from other fields to set another field, right? So then this becomes a problem, because if I say update manager data, manager, and then first name equals Paulo, last name Alvarado, right? If I do manager.update fields, .save update fields, first name, last name, when save is called, Django is going to concatenate first name, last name, and it's going to set full name, but full name is never going to make it into the database, because I'm saying to Django only update first name and last name. So this can be a problem in third-party applications. Like if you're handling data for third-party applications, this is a problem. So if you were to use update fields, you need to make sure that you always look at the code, always look at what these third-party apps are doing. They could be doing something in the signal handling, like in the pre-save, or on the save method. So just things to watch out for. Now, normally in Django, we're all used to doing, in this case, hotel.objects.all, right? Give me all the hotels, and that would also give me all the fields for the hotel, right? Very common. But normally, you don't necessarily need all the data for the hotels, right? If you just want to print the name of the hotel, you don't need when was the last modified, you don't need the manager or any of that, right? So Django gives you the only method, right? Here I've got two functions, print hotel names v1 and print hotels names v2. The first one fetches all the hotels, right? And just prints the hotel name. But the first one also fetches all the other fields, like manager, the time that it was changed, and all these other fields. The second one simply fetches the name. That's all it fetches. It still uses the ORM to create an instance of the hotel, but it only fetches from the database the name field. If you look at the timings at the top, you'll see that there's really not that much difference. One is 0.175, the other one is 0.173, right? I think I ran this on 500 hotels with, I think, 1,000 time repetition, something like this. And yeah, no, the timing is really not that big of a deal. Like, there's not that much of a difference, but in my case, hotel is a really simple model with like 5 fields. If you've got a model with 50 fields, and these fields are complex, like big text fields and things like this, then it's going to start making a difference. Django also gives you two other options. The other one is values, right? It works exactly the same way as only. You pass in the field name, in this case, name, and it returns a dictionary, right, for each object in the values query set. It's not a normal query set, it's a values query set. So it returns a dictionary. As you can see, it's significantly faster. Like the other ones are 0.17, V3 is 0.07. So there is a big jump, like a big difference in performance. And if you look at before, it uses values list, which is exactly the same thing as values, except that instead of returning a dictionary mapping field name and value, it returns a list of tuples, or an iterable values list query set of tuples. And these tuples include the values for the name that you're asking, for the field that you're asking for. So in this case, it would be name. So it would be a list of tuples whose only item is the name, the value name. So we can tell Django, because we only need one single value, we can tell Django flat equals true, and it will return a flat list instead of a list of tuples with only one item in there. And so you can see that values list is faster than values, right? And I don't think this is much because of the database. I think at this point, this is more like having to create a dictionary versus a flat list. Because if I'm not mistaken, I think these two do exactly the same thing at the database level. They only fetch that one value, and then the difference is at the ORM level. Here's a quick example of how you could use something like values list to, in this case, export hotels, right? I've heard a lot that sometimes developers don't really know how to leverage these things, the values list or values. And here's a quick example, right? I know there's libraries to create CSV that are better, but I say values list, PK name, city, postcode, create the CSV writer, pass in the header row, and then I give it the iterator of the values list query set. So it's efficient because it's only fetching those 4 fields, and it's using the iterator of a query set versus loading the entire thing in memory. So yeah, much more efficient. One thing about iterator though is when you do something like query set.all, Django will actually call that iterator, but it will evaluate it immediately. It will literally do list and then query set.iterator, store the results in an internal variable in the query set. So the next time you do .all, it's going to just call that variable. But so if you're just iterating over something and you're not necessarily going to iterate over it again, this is why it's much more efficient memory-wise to use iterator, because you don't load everything at once in memory, and you don't keep the extra variable, like all those results in memory either. So just a quick note on iterator. Now, templates. So templates, I've got 4 topics. The first one is cache template loader. This affects projects only. The second one, per request cache templates. I'll explain that in a bit. It affects applications like the CMS or other third-party applications that you're distributing. Then fragment caching and a note on template logic versus template tags. Cache template loader. So imagine you've got a project that renders in one single request, it renders, I don't know, 100 templates. On the CMS, this is this happens a lot because a CMS page is composed of 300, 400 plugins. Each plugin renders its own template. So it is a valid case, at least it was for us. And every time you do an include in Django, you use the include tag on the template, or anytime you do render to string or render template, Django is going to look up the template with the path you're giving it in the file system, fetch it, compile the template into nodes in memory, and then render it. And if you're doing this for 300, 400 templates, it's going to be extremely expensive because Django is going to literally do that same process 300, 400 times. And it doesn't matter if it's the same template. Like on the CMS, you could have 300 text plugins all render the same template, and Django is still going to go to the file system, compile the template into nodes, render it 300 times. So this is why there is the cache template loader. So Django gives you the option to configure different template loaders, like from the file system, app directories. And the cache template loader wraps all the other template loaders, right? So it doesn't really care how templates are loaded. All it does is whenever a template is fetched using any of the template loaders that matched, it caches in memory. It does not use Django's cache framework at all. It just in-memory caching of the template. So the path to the compiled template node in memory. So the next time that template shows up, Django doesn't have to fetch it from the file system, compile it into nodes, and do all that. It already has it in memory. So this is really useful when your project is up and running already on a live server, and the Django process usually lives for a long time. So the first time the request hits the server, all the templates or a bunch of templates get cached. The second request, they're already cached, and so on and on. It would only change if you were to restart the server or something like this, restart the Django process, then those templates are removed from the cache and they'll have to be populated again. But this can bite you if you're using it locally, because locally, usually when you're developing, you're changing templates, you're doing all sorts of things, right? And at least I'm used to that if I were to change a template, the modification is immediate. Like I can just reload the page and I can see the modification. But if you're using cache template loader locally, that's not going to happen because it's cached in memory as long as the process is running, right? So if you're using cache template loader locally, you're going to have to restart the Django server every single time you make a modification to the templates. And so that can be quite annoying. And so brings us to the next point. If you are a third-party application developer, right, like the CMS, you cannot assume or rely on people using the cache template loader. You cannot say, well, everybody has to use the cache template loader because otherwise the CMS is not going to be performant or my app is not going to perform. No, it has to perform regardless of whether they're using the cache template loader or not. I mean, it's going to perform better with the cache template loader, but the app still has to load properly because people still need to develop locally, and it would be a nightmare if it doesn't perform properly, right? So in the case of the 300 plugins, it should not make, if the 300 plugins all render the same template, the application needs to be smart enough to not do it 300 times, only do it once, regardless of whether you're using cache template loader or not, right? In this example, imagine I've got 200 hotels. Before Django 1.9, this code would compile the template into nodes 200 times, every single time for the hotels. Django 1.9 introduced caching for the include tag. So now it would only compile it into nodes one time after Django 1.9, and then the next time it would use the cached solution. But you still have a problem when some water. You still have a problem when you want to render the template in Python code, like when you're using render to string or something like this, like the CMS does. You have the problem. Like the include tag, fine, it's solved after Django 1.9. But for all other cases, you still have a problem. So I'm going to switch to Python for a second. I hope that is not visible. Wow. Okay, I cannot for the life of me figure out how to make this bigger. Shoot. Okay. Okay, I think that's better. So this is one solution, right? I'm not saying like this is how you're going to how you're going to solve it every single time. But on the CMS, what I came up with was this concept of on-request cached templates. So instead of caching the template for the duration of the server, right? Like I could have cached all the plugin templates as soon as the server starts, and then the problem is solved. But I'm not going to do that because then I would limit the developers to have to restart the server every single time they make a change in the template. So instead, I did this like on-request cache template loaders. Well, not loader, that's a bad name. But on-request templates where it's very simple. I have like this class which has a get cache templates. All it does is it looks up the templates in this cache _cache templates dictionary. If it doesn't exist, fetches the template, sets it there. Exactly the same way that Django's cache template loader works. And then for templates that are already known to me, like the hotel info template and the hotel teaser template that are used in the list of hotels, I can just define them there directly. And I can even use cache property to over-engineer a little bit more, and so that it doesn't even go to get cache template a second time. It would be cached immediately after the first call. And the way I would use this is, oops, come on, wait. Okay, there you go. Go that way. Okay. A context processor. A context processor is called on every request, right? So in the CMS, I simply introduced a context processor that will provide me with an instance of this class. And then I can easily use this, switching back to the presentation. And I need to figure out how to undo this. Wait. It's not undoing. It's not escaping. Wait. Nope. Okay. Jesus. Live demo problems. What? Wait. I can't figure out. Wait a second. It's not like. Okay. Technical difficulties. I think I got it. Nope. On the Python. Yeah, I used the like the 2-finger thing, and now it's like not doing it.
Oh, I think it's because you're in focus on the presentation app, which zooms differently. If you go to just any other app, if you go out of Keynote, focus on another app, I think zoom in.
Okay, like there.
Yeah,
but
outside of the text, I think.
okay.
It's those fields use the same gestures.
Yeah, that are good at the desktop.
Okay, I am losing too much time on this.
Maybe you can go to the desktop, out on the desktop from there.
Ah, damn it. Wait. I really should not have zoomed in. Okay. I need to think this through. It's not zooming out. Okay, I can't seem to figure this out. So I'm gonna have to improvise. Okay. That is not as visible as it was before, but improvising. Okay, so on the context, I put in this hotel templates instance. And the hotel templates instance has the templates that I want to cache, right? So on every single request, I would basically have this hotel info, and it would be fetched only once per request. And if I were to call it again, in this case, for hotel and hotels, right, 200 hotels, it's only fetched once. And the other 199 times, it's not fetched again. So, and this solution can be used inside of template tags, Python code, all sorts of things like that. So that would be one way of working around the cache template loader on a third-party application, right? And I have to move fast. Okay. I'm going to skip all this and just do that. I think this is more important. I've seen a lot of templates where there's a lot of logic, right? So normally Django tells you don't put logic in templates. You know, the more logic you put, the slower the template will be. And that is 100% true. Like, if you've got a lot of context variables in your template, if you've got a lot of like loops, like if statements and things like this, your template is going to render very slow. And so imagine this loop here for plugin in plugins. Imagine that there's 200 plugins. Include this template, right? And you can't see this very well because it's like zoomed out. But this template comes from the CMS, actually. And it's a template I've contributed to, a lot of people have contributed to over the years. And you can't see it, but there's an insane amount of variables, conditions, filters, and all sorts of things like this. And this template was one of our biggest bottlenecks when we were like working with rendering of plugins. So one solution here is to just move logic from Django templates to Python code, right? We're Python developers. So a simple template tag, render plugin.js, and all those conditions, all that stuff can easily be moved to Python code. I didn't write everything because that would just take in the whole slide, but here I actually had to make a big, big decision. Should I put in one single line of JavaScript as a string in Python code? And at the end, I decided yes. So that line at the top is one line of JavaScript. That is what then gets rendered with all this configuration. But all the logic is in Python. And so in the case of 300 plugins, this literally took down like seconds of rendering time just by doing this simple thing. And that would be like that's the actual tag. The other one was a function called by the tag, and this would be the actual tag, right? Simple, very simple tag. And one last note, third-party applications. One thing we noticed is when we were deleting objects on the CMS, there was an insane amount of queries being made, and we had no idea why. And it turns out that because we use a third-party app, in this case, Treebeard, it has its own deletion logic, which would make an insane amount of queries to delete one single object. So when you're working on an application that uses other third-party applications that relies on them, make sure that you look at the code of these applications. Just the same way as I mentioned for the save method, make sure you look at the code for the third-party applications, because in order for you to know basically exactly what's really happening. So I've run out of time because of that technical difficulty. Thank you very much. Questions? Don't ask me about the zoom in thing because I don't know.
Really interesting. I've never seen the Django before, but is this as if you were explaining a theorem with the Django or the Django itself, or?
Sorry, I couldn't catch it.
Right. I've never seen the Django thing, and I'm really interested about it, but this is like an intermediate.
Yep.
That's why I'm kind of lost. So this is like you were explaining a theorem with the ORM.
Yep. Yep.
Alright. I'm kind of in the way. But you were to tell like the person that doesn't know what I'm a beginner in this because I'm a programmer, but on this, what would you tell like for the conclusion?
For the conclusion of like the
Where do can I start looking to know more about this?
to know more about performance optimization, or in general, I'd always say the documentation, but my preference is always the code. I think the best way you can learn something is by looking at its source code. And so that's personally what I do all the time. I just look at Django source code. And in regards to performance, I find the debug toolbar, either the toolbar that shows up on the side, right, or the debug toolbar's debug SQL shell. I use that a lot to understand all the queries that are being made. So there is like this management command that drops you into a shell, and any ORM call you make will print out the SQL that's being called. So that's really useful.
So we ran out of questions.
If you have a question, you can catch me later. Thank you. Sorry about that.